Hello everybody. I am Rituja Sangeet Rao, the GDSC lead of Cummins College of Engineering. Welcome everybody. I welcome you to this session, to this YouTube Live with Introduction to Google Cloud. We have Vijeta Pai. She's a Google Cloud accredited and accredited technical evangelist who is recognized as an expert in Google Cloud. She's an experience in implementing strategies and and strategies and training globally to provide competitive edge in organizations in diverse, evolving customer environments. She's the creator of Cloud Demystify and working on her passion to demystify cloud technologies using webcomics, animated videos, and infographics. So here I call upon her to the stage. Hi, Vijeta.
Hi. Thanks a lot, Rutuja, for the wonderful introduction, and thanks a lot for having me in this session in the first place.
Yes, I am super excited, and I hope all the participants are super excited also. All of you, if you're excited, can we type in a yes in the chat box? Can we type in a yes in the chat box? Vijita, you'll see the chat box on
Sure.
the right side. Yeah. There's a little bit delay, but we'll have that. Yeah. You can see the messages. So I'm pretty sure all of you are excited to to know more about cloud, to understand the basics of our cloud and how, yes, now we see all of the yeses. All of them are excited. So, yes, a lot of them are excited. A lot of them have joined in. So let's continue the session. You can take ahead.
Sure. Thank you so much. And like I said, thanks for the introduction and thanks for having me in here. And let me get started without wasting much time. So I'll start sharing my screen. And I'm going to share my entire screen because I'm going to keep navigating between the demo and the presentation. So just so you people know, what things look like. So there you go. I'll just start off with this presentation. Yeah, so thanks everyone. I'm Vijeta here, and I'm a Google Developer Expert or a GD in Google Cloud. And I'm just going to start off here and introduce you to Google Cloud Platform. So some ground rules here. So I'm actually first going to go over my presentation, and after that, if you people have any questions, you can just type it in the chat box. Rutuja will help me with that later. But I'm going to take all the questions towards the end. So as and when you think about them, keep jotting them in, make notes, just put them in chat. I'm going to take it at the end of the presentation. And since this is an introductory session, it may seem a little basic for some people towards the beginning, but then I'm going to do a little bit of deep dive as and when we move along the slides. And towards the end, I would have a list of courses and a list of resources that you can leverage in case you want to learn more or grow more in the cloud. So it's going to cover introductory to intermediate knowledge. So in case you're finding it too basic towards the beginning, you already know about the cloud platform, just hold on. I'll be reaching to the other stage as well. So I'll just start off with this presentation. So cloud computing. What is cloud computing? There's so much buzz around cloud computing these days. You might have heard about it on LinkedIn or any other medium. And many companies are actually moving to the cloud. So what is cloud computing and what do we mean by moving to the cloud? It's not an abstract term, but it's actually really, really simple. Let's take any application or any organization, for example. StreamYard that you're using right now. Let me take this particular example. A lot of us are using this particular application, and there's a lot of data that comes in this application, which is same for any company. So any company or any organization you can think about, or even a personal website for that matter, has a lot of data involved in it. So what do we do with that kind of data, and how do we make sure our users are accessing our website? For that, there's something called a physical data center. What is a data center? Data center is nothing but an open space that is filled with racks, different servers, and different hardware in an open space, which is actually used to collect, process, and also delete if needed or archive data. So companies, when they start out, or if they don't have a cloud model, or if they have an on-premise model, they usually have a lot of racks and servers, storage space, and everything is really physical. Think about it like a big room, more than a room. It's actually buildings and buildings sometimes, having a lot of physical hardware. Now, what happens with physical hardware? You all have experienced that in your house or just in your college as well. All physical, with physical hardware, we have a lot of maintenance that comes in. For example, electricity goes down, you need to have backup, you need to pay for the electricity. Or let's say something stops working, you need to have an entire team whom you need to send on site to the data center so they can just check what is happening. I'll just give an example. I was working at Akamai Technologies, and I one day my application stopped running. I had an entire team debug it, just take care of it, but nothing. I mean, it wasn't working up. We spent an entire day trying to debug. Finally, we realized that someone had unplugged one of our servers from the plug. I mean, it was as simple as that. Some worker or some person at the data center had just unplugged the server. And we spent an entire day trying to debug something that was actually a physical problem. So that's what happens with the data center. And it is not just one or two machines we're talking about, thousands and thousands of machines would be there. So, because of this, there's a lot of data that comes in, and data is power. With data, you have a lot of power in your hands. Like you can run analytics, you can run area reporting, but we need a very nice way to store, analyze, and process the data. Remember these three: store, analyze, and process the data. And also make sure the end user experience is well, because ultimately we want to keep our users happy. What happens then? Cloud computing comes into play. What is cloud computing? Cloud computing is nothing but a shared environment where servers, networks, storage, development tools, and applications are centrally hosted. What do I mean by all these mumbo jumbo and fancy terms? It just means instead of having a big physical data center and lots of racks and servers, everything is virtualized for you. That is, everything is presented to you in a virtual environment. You have virtual machines, you can run your applications virtually. Everything is at your disposal on a website. It just looks like any other website. All the hardware, backend, everything, maintenance, security patches, all of that is taken care of by the cloud provider, in this case, Google Cloud Provider. And you just have to worry about sanctioning a VM, customizing it, or if you're just a developer, get another service and just run your code in it. So it's basically a lot of it is managed for you, and you don't have to worry about any infrastructure overhead or just having a team take care of all the infrastructure needs. That is how what cloud computing does for you. Now, types of cloud providers. I mentioned Google Cloud Provider. There are other cloud providers in the market, but how do we really classify them? Cloud providers can either be public, private, or hybrid. What do I mean by all these terms? You all are in college right now, and some of you might be living in a PG, hostel, or any kind of shared accommodation. So imagine you're living in a PG and or a paying guest accommodation or a hostel, and you have a room that is shared with another roommate. So there are like 2 to 3 people in a room, but you have your own space. You have your own bed. You have your own maybe a small wardrobe, mirror, but the entire room is shared with 3 people. That is how a public cloud provider works. Google Cloud Platform provides space for organizations so they can have their own virtual private cloud, or they can have their own virtual machines that is shared within the space. But there are very clear boundaries, like one organization cannot really go into the other organization's resources. So that is how it is laid out. So basically, it's a space that is shared between organizations. Now, think about perhaps your parents want to visit you, and you realize, okay, this PG or this hostel would not work in that matter, because I want my parents to stay with me for 3 months, and they obviously cannot stay with me in a PG. What do? You just go out and try to rent a 1 bedroom apartment. So, when you rent a 1 bedroom apartment, you have the entire space all for yourself. But everything else, like the electricity or let's say the other infrastructure needs, are being taken care of by the landlord. Now, that is very akin to how we understand a private cloud provider. So, it is nothing but space that is exclusive for one organization. Some banks I know, I mean, because they're very concerned about their privacy, or they're very concerned about the data that goes inside, they prefer to have they prefer to engage with a private cloud provider. So now just think about the price that you pay for both of these. When you're renting a one-bedroom apartment, it can go very, very expensive, sometimes even up to 20,000. Compare that to a PG or a paying guest or a hostel accommodation where the room is shared with three people. It can be extremely affordable for you. The same thing applies to cloud providers as well. So if you are a private cloud provider, you end up charging a lot more compared to a public cloud provider, but just because the space is shared between organization. So while your virtual machine or any other resource is running on the cloud, you own it. After that, you can just give it up and that would be taken by someone else. That is how a public cloud provider works. Now, there are many organizations who are adopting a hybrid model or hybrid cloud. What do I mean by hybrid cloud? Hybrid is nothing but using both the public and the private cloud together. So you save on money, but at the same time, you also have your own private space inside the cloud as well. Very simple example. You decide you want to go back to the PG or you want to go back to the hostel, but this time you decide you want an individual room for yourself. What happens? You're not renting out an entire one-bedroom apartment because it's really expensive. You're just renting out one room where you are in the room all by yourself. You don't have a roommate in your room. You have your own privacy. You're not paying as much as paying a one-bedroom apartment, but at the same time, you're getting best of both the worlds. And all the infrastructure needs and everything else is getting taken care of by the landlord. Hybrid can also mean a model where a little bit of your resources are on premise and a little bit on cloud as well. I'll give an example. There are many people who were hesitant to move to Google Cloud because they had some Office 365 applications like Excel or Active Directory on Azure, on premise, and they didn't really want to move on to Google Cloud. What happens then? Then we adopt a hybrid model. So a little bit of their applications are on premise, some are on cloud, and there's a nice nexus between that. So that is what hybrid is about. Hybrid is basically making best use of both the worlds so we can give an optimal experience to our end users. Google Cloud Platform is a public cloud provider, and many companies, especially startups and big enterprises, are moving on to Google Cloud just to make use of all the features that they provide and just to have a seamless experience for the users. So I'll just give a quick Google Cloud Platform preview because here I've just been talking in the air and I don't want you to just get confused about what cloud looks like. So I'm going to move on to a demo here. Then I'm going to show you how a cloud platform actually looks like. So what you see here right now on the screen is Google Cloud Platform. So this is how your cloud looks like. It is not any mumbo jumbo going around. It's just plain simple English or any other language that you prefer. And it looks like any other website that you use. So here you can see there's a dashboard in which it's like a one-stop shop. You can also customize your dashboard. If you don't want to see something or something is more important for you, like for example, billing is more important for you, you can just move it on top so you know you're not spending a lot of money. Then you have activity, you can monitor activity, you have recommendations, and then you have a nice menu bar here in which everything is available at your disposal. Like you have different services that you can use, your operations. You can also monitor and track what you have. You have different tools, third-party tools as well, APIs, everything else is provided to you here in the platform, whether it is artificial intelligence, whether it is just having big data, some of the analytics that you need to run or tools, anything you need is there for you. And as you see, this is the one, because I said this is a one-stop shop. You can also navigate between your projects. Like if you have another project, you can choose that. You can search for products and resources here. You can actually move to the billing section here to make sure that you are not spending a lot of money. You can set up alerts. Okay, if my bill goes about $200, send me an alert. You have monitoring. So by monitoring, you can monitor what is happening to your applications. Are the people coming in? Is there any suspicious activity going on? Is there any downtime that is happening? Everything else can be customized here. And of course, you have the news and documentation in case you want to explore more. So you have a getting started guide for everything, just so you can get a demo of how to use the console. This is how a cloud platform looks like. This is how Google Cloud looks like for you. And just compare this to a big data center where you have a big room with so many machines, wires, maintenance. It seems so much more intuitive, right? This is because everything has been virtualized for you. Remember this term virtualized. Your virtual private cloud, virtual machines, everything is in the virtual environment for you. And just at a click of a button, you can sanction everything. Like I'll just show an example here. I'll just move on to the menu bar like I just did. I'll move to Compute Engine. So Compute Engine is Google's infrastructure as a service offering using which you can create a virtual machine. You just click on VM instances here. And while this is loading, I'll tell you. So this is a very simple way for you to create a virtual machine. What is a virtual machine? It is just a physical machine that has been virtualized. So you can use Google's Google Cloud infrastructure to run your applications. It's an infrastructure as a service offering. So using this, you have different VM instances here, and you can just create a virtual machine for yourself. So you can, for example, click on this and create an instance. I'm not really going to create it for you here because I don't want to get built, but I can show you how to create it. So you can create an instance. For example, you can say instance 1, or let's say demo. And you can add different labels. You can choose your region, zone, anything you want. Look at all the customization that's available for you. So you can use the GPU, CPU, anything you can choose for yourself depending upon the amount of load you're expecting on the application. And then you have different firewall rules like allowing the traffic, and then networking this security, anything to do with security firewall rules. And you just need to click a create button. So the minute you click on a create button, the virtual machine will be created for you. And like you can see on the right hand side, you can see the monthly estimate as well. So it's going to cost you $25.46 monthly, depending upon the customization you choose. The minute you change your customization, the price is also going to change for you. Like for example, if I choose more memory, let me just go on to something more. You can see it turns to 98.84. So here you can see at just your fingertips how much it's going to cost you, how much of load is it going to take. Is this really worth that much, or do you really need that much of memory? So you can easily customize it the way you want to. And you would also get, this is a nice way for you to keep everything organized. Compare this to a physical data center where you really don't know what is happening. You need to learn how to use the machines. This is how a cloud platform looks like. And I'll move on to the presentation now. This is the Google Cloud Platform preview. And next now, I'm going to discuss what are the advantages of moving to the cloud. I have touched upon some things, but I really want to elaborate on those now. First thing is data processing and analytics. Like I said, data is power. Remember that. No matter which organization you join after your college, data is power. So the more data you have, the more analytics you can run on that data just to make sure your users have a seamless experience, and you as an organization are actually having good changes, upgrades, and just running analytics for any kind of, let's say, improvements for yourself. Also, analytics can be run on analyzing, let's say, crash reports or why your application is going down. There's a variety of things you can do, and there's a big stream for that big data. So basically, you have all the data inside the cloud, and Google Cloud Platform has really good analytics and tools for you to analyze your data, store and analyze. Next, we have agility. What is agility? You must have been hearing this term also. Agility is the ability to adapt quickly to change. As you can imagine, in this pandemic world especially, there are so many applications here who have more and more users getting onboarded. There are a lot of changes that people need to make. Like many people have to move on to a virtual model just because of the way things are. And having a physical data center makes you a little slower compared to having a cloud provider. So in that, you can quickly change your customization. Like you saw, it's just a click of button. You can change your customization. You can onboard more users. You can maybe have more applications that you want to run on the cloud. You realize an application is not working, just decommission it. It is as simple as that compared to buying machines and just managing it out there. Next, we have scalability. I touched upon this a little while ago that with more and more users coming on, sometimes it's very, very difficult to keep up with the traffic. So it's very important for applications to be scalable. What is scalable? Scalable is the ability to move up and down based on load, just to make sure that your application is running seamlessly. So there are times, for example, at 4 a.m. at night, many users might not be using our application, but the minute it is 10 a.m. or something, there are a lot of users who are coming out. Now, you want to make sure that when there are more users coming in, you don't want your application to crash. And when there are less users, you don't want to be paying for more, right? I mean, you need to make sure that your application scales up and down based on load. So you as an organization can make the best use of your money and you can give your users a seamless experience. Cloud provides you with that. So there are elastic scaling or automatic scaling that is available, or you can set up manual scaling tools based on which you can scale up and down based on the number of users coming in. Next, we have lower infrastructure maintenance. And this I've told a lot of times in this particular presentation, that you don't have to really worry about any kind of infrastructure maintenance because everything is in a virtual environment. And next, we have lower cost. So you might be thinking, this is counterproductive. If I have to pay $100 per virtual machine, how are you saying the cost is lower? So Google Cloud Platform, first of all, you are saving on the infrastructure cost. You're saving on paying an entire team to take care of your infrastructure. You're saving on the space you're renting out for a data center. You're saving on different machines that you need to buy. And at the same time, if you want, Google Cloud Platform provides you with committed and sustained use discounts as well. So, for example, you want a virtual machine for 5 years, and you just contact Google. Okay, I want to commit to this particular resource for 5 years. They have excellent discounts and pricing model for you. So that way, you actually end up saving a lot more than you would spend otherwise. So all these flexibility and advantages are provided to you by a cloud provider. Now, what are some of the cloud services? I have mentioned infrastructure as a service a while ago, but what are these cloud services? First, we have infrastructure as a service or IaaS. We have platform as a service or PaaS. And next, we have software as a service or SaaS. What is infrastructure as a service? Infrastructure as a service is the service provided by Google Cloud Platform where the hardware is provided to you by Google. And platform as a service is a service when hardware and the operating system is provided to you. Software as a service is when hardware and software is also provided to you. I'll explain this with a very simple example. Suppose you want to rent out a one-bedroom apartment. There are three options available for you. You just go and check out the first option. In the first option, you have been shown a completely unfurnished house. What do I mean by completely unfurnished? There's just one space available. You have to put the light, fan, fixtures, furnitures, everything you have to put on your own. That is how infrastructure as a service would look like in a cloud world. Compute engine, like I just showed right now, if you remember, everything you had to customize on your own. You were just given a virtual machine. You had to customize the region where you wanted it. You had to customize everything else, usage, and accordingly, your price would have changed. So everything is in your hands. That is how infrastructure as a service works like. It is like an unfurnished house. You want a blue light, put on a blue light. You want a red light, go ahead and do that. That is how infrastructure as a service works. What is platform as a service then? You decide, okay, this is a lot of work. I don't want to buy my own light and fan and everything. So I go to another apartment. This particular apartment is semi-furnished. In that, the light and the fan and all the fixtures are provided to you, but you have to get your own furniture. Or you have to get your own sofa, your own bed, everything else. All the furniture needs to be bought by you. This is similar to platform as a service where the hardware and the operating system is provided to you by Google Cloud. This has less customization compared to infrastructure as a service. But if you have a team that is not very dedicated to all of this, as in they don't have a lot of cloud knowledge, or you don't want to waste an entire team just to handle cloud administration, you can have this particular option. This is somewhere between managed and customizable. So part of it is managed by Google Cloud and part of it is customizable. Next, you realize, no, I don't want to buy my own furniture. Why should I spend so much money when I'm anyway going to move out in a year? There comes software as a service for you. So in that, your entire apartment is furnished. So by furnished, I mean the light, fixtures, furniture, everything is provided to you. You just need to get all your stuff, your plates, your clothes, and start living there. That is how software as a service looks like. So in that, the hardware and the software both is provided to you. So this can be as simple as just going and using an application or just running your code in it. So it's really good for developers when there's not a big team present for exclusive cloud administration. Another very simple example of software as a service is Google Drive, which you might be using. What do you do there? Do you sanction a virtual machine? Do you choose the region? Do you choose the operating system? No, you don't choose any of that. You just go there, you upload your document, you just set permissions as and when required, and finally you have your application running there, or you just have your document shared. That is how software as a service looks like in the cloud world. Now, just a short demo because I've been talking about all of that, and I'll move on to the console again. So here we have our Google Cloud Console. So what I showed here with I just have the compute engine instance open here, the demo instance. Everything else was customizable for you. So you could choose the machine type, you could choose your operating system, everything else you could choose for yourself. If you see, there's so many options, and there are more. If I just open up the networking disk security management, just look at this. This is all the option that's provided to you. It's like an unfurnished house. You can furnish it the way you want to. So this is how infrastructure as a service looks like, where everything is customizable by you, and a lot of it is not managed by the cloud provider. So this leaves a lot of room for, like I said, customization. Next, let me move on to another thing. I'll just show you. Let's say App Engine. So I'm going on to App Engine. So App Engine is actually Google Cloud's platform as a service offering. So I'm going to create, I've already created one. So let me do one thing. Let me create one more instance. Let me go on to the dashboard. Let me get started actually. So when you're creating an App Engine instance, you can actually choose, let me just see. Get started, learn. To delete this particular instance. Yeah. So when you go on to this, you are looking at the instance. So learn about instances and App Engine overview. I'm so sorry about that. Let me just go to the instance that I already have. Let me get started with that. So when you create an App Engine instance, you have to basically specify the region. By region, I mean the area, the location where you want your application to be in. And you have to specify the name and some of the other specifications. You don't really have to worry about setting the operating system because it's not that level of customizable. But at the same time, a lot of it is managed by Google Cloud for you. Now, what does that really mean? That means if you have a team that knows about cloud, but at the same time, you want a lot of it to be managed by Google Cloud, App Engine is the way to go about it. It's Google Cloud's platform as a service offering. Next, I move on to something called I'll move on to so let's say Firebase. Okay, let me move on to Cloud Run. So Cloud Run is basically some software as a service offering here. So if you go ahead and create a service, for example, you can just move on to this. You can set the URL or the name. You just have to change, okay, CPU is only allocated, auto scaling, and you have to specify how it is getting triggered. The minute you do that, you can set your instance. Now compare this to the compute engine instance that I had opened, looking at the amount of customization or the amount of information that you need to put in as compared to some of the platform as a service or a software as a service offering. And like I said, all this is maybe just too complex for you. Remember Google Drive. That is a very simple software as a service offering. All your applications are on the cloud, but you don't have to really customize anything. You're not being asked to choose your GPU usage, or you're not being asked to choose any of your regions, and you're not being asked to choose your operating system for sure. So that is how these services work. And depending upon your requirements for the organization, you can choose any of these services that's being provided by Google Cloud. And move on with the demo. Cloud security. Now, with all the applications that you have and all the cloud advantages that you're using, cloud security becomes very, very important because we have to, or we need to make sure that our applications are really secure. What is cloud security? Cloud security basically is their technologies processes, policies, and controls to make sure your applications are secure on cloud. Cloud security is not just about having a tool to run a security check and be done with it. No, it is actually an entire process or an entire flow that you design to make sure your applications are secure on the cloud. What do I really mean by that? Let's say, for example, you have a virtual machine on the cloud. You have to make sure that it is secure, right? A lot of security, like encryption and all, is provided to you by Google Cloud Platform. But at the same time, you have to make sure there's an additional layer of security from your end. Let me give a very simple example, moving away from the cloud console, that you are using Google Drive or Google Workspace for that matter. And in that, you have created a new file. After that, you go to permissions and you give someone a viewer permission, you give someone an editor permission. You don't give everyone an editor permission, right? That is also one security best practice. That if people don't need to do anything to a document, just give them viewer access. Let them just view so they don't mess with the document. This is very similar to how we understand cloud security. So not only do we have technologies and controls to make sure that our applications are secure on the cloud, you need to have really good organizational policies and processes to make sure that everyone in the organization understands why you need to secure your applications and how you can secure your applications. Google Cloud has a really good support for cloud security. So if you're an organization who has decided to move on to Google Cloud, you can always engage with the cloud team at Google, and they can help you with all the security best practices, processes, policies. And also, for example, there are some compliance standards you need to meet, like PCI compliance. If you have a lot of credit card information, they are going to help you with that. So that is what cloud security is all about. And you have to remember that security is a shared responsibility. What do I mean by a shared responsibility? You cannot just leave security on Google Cloud Platform and expect them to just take care of all the security needs. You need to make sure that you also are equally involved in the security model. And it works the other way around as well. A cloud provider cannot expect you to take care of all the security, everything related to security. There's actually a really good responsibility model, or let's say a really good sharing of responsibilities to make sure that your applications are secure on the cloud. It's like a symbiotic relationship between the two. I'll just give an example here. Of course, this is not an exhaustive list, but this is a shared responsibility model that's being commonly followed, and it can waver, it can change according to the needs and according to the requirements. But so every cloud application, irrespective of whether it is infrastructure as a service, platform as a service, or software as a service, has people, data, application, and operating system in it. What do I mean by that? People are basically people inside and outside your organization who can access your particular application. So they may be your internal employees, your internal team, or it can be people, the users. So all of these, all of that comes under the bracket of people. So people basically mean the physical people or the machines or the service accounts that are involved with your application in any way. Always remember, whether people are inside your organization or outside your organization, it is very important to have a zero trust model. By zero trust, I mean the same amount of policies and processes applied to both inside and outside your organization. If there's an application, make sure that people inside the organization also have a multi-factor or dual-factor authorization or authentication involved as the people outside the organization. I'll come into that in a short while, why that is so important. Now, next we have data. Data. This is what I've been talking about since the beginning of my presentation. There's a lot of data that comes into your application, whether it is user data, whether it is internal data, whether it is any kind of error report. So there's a lot of data that comes into any kind of application. So that also falls under whether it is an infrastructure as a service, platform as a service, or software as a service. Data is extremely important to understand. Next, we have the applications. So basically, these are the applications like the virtual machine I had just run a while ago, or any other application that you have on the cloud. And last, we have the operating system. So operating system is basically the operating system that the application is running on and in the cloud. So I'll just present you a small shared responsibility model to understand how shared responsibility looks like. Now, for infrastructure as a service, people, data, applications, and operating system is the responsibility of the user or the organization. That little figure you see there, it denotes a user. What do I mean by that? Because infrastructure as a service is highly customizable. I just showed you computer engine a while ago, right? It's highly customizable. Because it is highly customizable, all the people, data, application, and operating system security is the responsibility of the organization or is the responsibility of the team that is managing the particular service. What do I mean by that? So people should get the right accesses, which I just talked about a while ago. Data needs to be secure and data needs to be encrypted. If there's an additional layer of encryption that needs to be put in, go ahead and do that. So data protection is your responsibility. Application. So any security features like firewall rules or anything else you need to set on an application front, your responsibility. Next is operating system. So any kind of security patches that come on the operating system, your responsibility to upgrade it. Just because it is so highly customizable, you have the responsibility primarily falls on the organization. Next, we have platform as a service. In this, people, data, and applications are the responsibility of the organization or your responsibility. Now let's come on to the operating system. Do you remember what I told you about operating system a while ago? That when you're using platform as a service, the operating system is chosen by the cloud provider for you. So Google Cloud chooses the operating system for any of your instances, or you have really small list of customizable operating system. Because of that, any kind of security patches that come on the operating system or any kind of security related to the operating system is the responsibility of the cloud provider. Next, we have software as a service. Just think about Google Drive because that's something you all might be familiar with. People, yes, you take care of that. You make sure that people are your responsibility, by which I mean you set permissions, you give edit, viewer access depending upon the amount of level of permission that needs to be given in. Next, we have the data. Data is your responsibility. You need to make sure your data is safe, right? Don't put any private data inside it. Don't put your passwords without encrypting it. All of that data is your responsibility. Application. So when you're on Google Drive, do you actually involve yourself with the backend application or code? You don't. So any kind of security patches or any kind of security that is associated with application is the responsibility of the cloud provider. Same with operating system, it's the responsibility of the cloud provider. So just because this is a highly managed service, software as a service, applications and operating system security is being taken care of by the cloud provider. But remember, people and data always your responsibility. You need to make sure people have the right accesses. You need to make sure that people inside and outside the organizations are going through a good security process in order to gain access to your data. Because there can be various amount or number of threats that come in. Like there can be people who are impersonating as someone within your organization, like I'll just give an example. So I was working at Akamai, someone's password actually got stolen by a person outside the organization. The minute that happened, they could actually log into the applications. We don't really want that to happen, right? That's why we need to have a layer of security, like an SMS needs to be sent on the mobile phone of the particular employee. So if their password, for example, got stolen or got leaked, they can always, they know that they are not going to share the OTP with the user, so the user cannot get in. So having different layer of authentications, having really good security best practices to make sure that only right people have access to your application is very important. Next, we have data. So data security is always your responsibility. A cloud provider cannot do much if your data is compromised. So always remember, people, data is your responsibility, irrespective of the security model you follow, whether it's infrastructure as a service, platform as a service, or software as a service. Moving on, some of the security best practices. I've touched upon this a little bit, but here I go again. So identity and access management. What is identity and access management? You might be hearing this term IAM all many times, and actually that's a buzzword that's going around in the cloud security space. Identity and access management is nothing but managing identities and accesses to your application just to make sure that only the right people have right access to your applications. So this is not as simple as just giving viewer or editor access. It goes way beyond that, because a cloud provider has different let's say gradations, or different ways you can access identity and management. It's a big topic, so I won't just dive into that right now, but it is something that you need to take into consideration. Next, you have active monitoring. What do you mean by active monitoring? So it is actually like having a CCTV outside a shop. So you know that, of course, you have closed your doors, everything is safe and secure inside, but still you have a CCTV outside to monitor. What if there's a person who's constantly looking inside to make sure that, just to find some vulnerabilities? You have to make sure that you address that particular concern. So monitoring is very important when it comes to any kind of application. So you can have various triggers. If something seems off to you, you can always go and investigate that. So being proactive is very important as being compared to being reactive, because sometimes being reactive is too late. Some of your user data might be compromised. For example, if your users have credit card information in your application, it might be compromised, and then users won't trust you again. Like, I wouldn't trust a company who would compromise my credit card information. So having active monitoring is the first step to having a really good security model, because you have to make sure that you are addressing any security concerns proactively rather than reactively. Now, next we have firewalls. What is a firewall? Firewall is deciding what traffic comes inside and what traffic goes outside the application. Sometimes it's like a window. You're looking outside, very good, everyone is going outside and you can see everything, but you have a tinted glass outside just to make sure that people outside cannot peek in your home, because that would of course intrude your privacy. So having those rules for any kind of virtual machine or any kind of resource on the cloud is very important, so you can monitor the traffic, or let's say you can set boundaries for the traffic that goes inside and outside your application. Next, we have data encryption. What is data encryption? Data encryption is nothing but storing the data in a format that is not easily understandable in case someone does get access to your application. I'll give a very simple example. Like, there's some websites in which you have to enter your password, right? So the minute you enter your password, it gets stored in star, star, or some weird symbols. That is what encryption is about. So even if I'm peeking while you're typing your password, I can still not make out what the password is, because all I can see is star, 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 star. That is encryption. So always remember, data needs to be encrypted in transit, at rest, and during use. What do I mean by those terms? Data needs to be encrypted in transit, which means when the data is moving through the application, it needs to be encrypted. At rest, it needs to be encrypted, which means that even when the data is getting stored in the backend, it needs to be encrypted. So even if a hacker gains access to your stored data, there can be a lot of information out there as well. It needs to be encrypted. And when the data is being used, like for example, someone is shopping and they are in the process of shopping, even then data needs to be encrypted, just to make sure that the data, even if someone gains access, you have all the security measures, but still some hacker gains access to it or some unwanted person gets access, they're not able to understand what the data is. So last, we have testing. What is testing? Testing is just testing, or let's say attacking your structure from the inside, or an application from the inside, to make sure that any vulnerabilities or any let's say slippages are countered at that moment itself. All companies have testing teams, or let's say they have some teams who actually do testing. Some have testers, manual testers, automated testers, or at this functional testers. And some companies actually have developers do the testing before deploying an application out. So by testing, you can make sure your structure is safe and secure from inside. It's like attacking your house from inside. You can keep knocking and you can keep hitting the walls to make sure there's no vulnerability for any thief to get inside. So testing is very important, because sometimes even after having everything in place, there's a small opening or a small vulnerability that a hacker or an attacker can use to get into your application and compromise your data. That's why testing is so important. Next, we have AI, ML, and deep learning. So like I said, cloud has a lot of services for you. So some of the services, like I talked about, having virtual machine, you can build your own applications on the cloud, you can build your own software on the cloud, you can just have maybe a web application, you can have a mobile application, you can have all of that in the cloud. You can store your data, like you can, if you have a lot of data, you can just store it and you can use that data for further analysis whenever needed. So cloud gives you really good services or products to store your data as well. Next, we have analytics, like I said. So you can have a lot of data, you can just store them in tables and you can analyze the data for your own needs. That is also provided by cloud. Next, we have AI, ML, or deep learning capabilities that's being provided by the cloud. So there's a lot of data that comes into the cloud. And with so much of data, you always have the capability of analyzing that data and using it for any of the artificial learning or machine learning capabilities. What do I mean by these mumbo jumbo terms? Artificial intelligence. I just explained this. So, any of these terms basically mean teaching machines to think and behave like humans. I'm not talking about creating a humanoid here, but basically feeding algorithms into their memories so they mimic human behavior. So, artificial intelligence is incorporating human intelligence into machines. It's an academic division that gets machines to mimic human behavior and intelligence. I'll just give a small example. All of you might be using some kind of assistant at some point, like you might have used Siri or you might have used Alexa, okay Google, Google Assistant, any kind of assistant that you use. What do? You just tell Alexa, tell me how's the weather outside. What happens then? As soon as you ask a question to any of these machines or any of these assistants, there's an equation that it refers to in the background. It picks out a keyword. Like your keyword, for example, is weather. Alexa will pick out the keyword. It will refer to an algorithm that's being stored in it. Weather, so there's an if then else loop out there. So if user asks about the weather, give them this answer. So Alexa will just search, okay, it's 20 degrees outside. It will tell you the answer. So it's just a simple equation that it refers to, and it gets to mimic human behavior. Why do I say human behavior here? I mean, I don't have algorithms in my brain. Or do I have algorithms in my brain? Let us think about a little kid. I have a 2-year-old daughter at home. So while she was just learning to just learn words, or she was just learning to walk, she realized that if she ran against the wall, her head is going to get hurt. One day she did that. She got really badly hurt because she just ran into a wall. The next day she realized, okay, this is going to hurt me. So I'm not going to run into the wall. I'm going to run in an open space. What happened there? There was an equation that got fed into her mind. Running into a wall equal to ouch. It's going to I'm going to feel hurt if I run into a wall. So the next time she saw a wall, she recognized this particular equation. First time, this was a process of cognition, like she learned the information. Next time, she recognized that information. There's a recognition that happened. So the minute she realized that it's going to be hurt, I mean, if I run into a wall, the equation got highlighted in her brain and she just changed her direction. That is why I said mimic human behavior. That is what artificial intelligence, machines do. Only difference is for the machines, all of this needs to be controlled by a human. They need to keep feeding in the equations. They need to keep modifying it depending upon the requirements. But the machine refers to that whenever they face something familiar that has been already fed into them. Or if they don't face something familiar, there's always a fallback option available to them. Next, we have machine learning. What is machine learning? So machine learning is teaching computers to learn like humans. It's not just think or mimic human behavior, but also learn patterns like humans. It's a subdivision of artificial intelligence that mimics the process by which humans learn. So basically, humans feed an algorithm into the computer memory and they learn to make logical deductions and follow similar patterns to respond. Like just having a simple equation, what is the weather, equal to tell me the weather, it's really simple. It's just referring to an algorithm. Now, what if the user frames it a little differently? Hey, Alexa, is it warm outside? Did they use the keyword weather? No, they didn't use the keyword weather. They just said, hey, Alexa, is it warm outside? The machine actually learns to make logical deductions. It made a logical deduction here that even though they're not asking me directly for the weather, they're indirectly asking me for a weather. There's another equation that is running in the background, and they still respond with, yes, it is 20 no, it is 20 degrees, it is not warm. So that is what machine learning is all about. It follows a really rigorous process of statistics, programming, and a lot of learning process that goes behind it, because it's not as simple as feeding an equation. That is what machine learning is all about, and it's a very good growing field right now, especially in the field of cloud technologies. Next, we have deep learning. So deep learning is a much more complex subset of machine learning, that it classifies information, identifies patterns, labels the information based on your previous experience, and compares it to similar data in order to make logical deductions. Just take a second to process this. What do I mean by all of that? My daughter, I just go back to my daughter for an example. My daughter went to a friend's place. So while she was just running around, she saw a door. What did she do? Did she just go and bang her head against the door? No, she did not bang her head against the door. She saw it, she remembered, oh, when I had banged my head against the wall, it hurt. So, door and wall look similar. Let me just classify it together. And she realized that banging against either the door or the wall is going to get hurt. And she just changed her direction. That is what deep learning is all about. Similar, when you're going to the field of deep learning, there's a lot of classification that is happening. So we have tables in which data is being classified, and similar patterns are being followed for data that are classified together. That actually mimics the process of the neural network in our body. It's actually inspired by that. What do I mean by the neural network? Neural network is just nothing but a collection of all the nerves in your body. So when you talk about deep learning, it is the way we respond. My finger gets hurt, my brain gets a signal. The nerve signal runs to my brain. I realize, okay, I have got hurt. Ouch, this is really hurting. I need to take care of this wound. What if my leg gets hurt? My brain receives a similar signal. Ouch, this is hurting. I need to take care of my leg. That is how deep learning works. All the information is classified into tables or classified together, and their response is formed on that particular classification. Why am I talking about all of this when you're talking about Google Cloud Platform? I'm talking about all of this because Google Cloud Platform provides a really nice space, or let's say a platform, because I've been using that term, to have all your machine learning and your deep learning applications in it. Organizations have a lot of data that they can leverage to run any kind of analytics, or have simple chatbots for that matter, just to make for a seamless user experience. So now companies can easily create a chatbot on Google Cloud Platform without having to worry about having a physical data center or a physical rack, server, or some physical entity. It is completely virtualized. It is extremely simple. So that is where cloud comes in. The project is created for you, or you can create your own if you want. The machine is sanctioned for you. You don't have to worry about the virtual machine, the memory usage. You don't really have to worry a lot about all of that. And it's very seamlessly helps you create your applications for AI, ML, or deep learning. Now, I've been talking a lot. Let me just go back to the demo and show you a little bit about artificial intelligence, machine learning. So what I'm going to do right now is a very fun activity. I'm going to show how to create your own simple chatbot. This is Dialogflow. So Dialogflow is actually provided to you by Google Cloud, in which you can create your own chatbot without having to write a single line of code. You heard that right, not a single line of code. It is a no-code platform, which means you can create everything at the click of a button. You just need to write, as long as you know English, you can create your own chatbot. I will just show you. I'll just expand this a little bit so you people can see what I'm doing. I hope my screen is visible at this moment, and I'm going to show you. So when you go into Dialogflow, first you'll be asked to sign in and just create a profile. I've already done that, so I'm not going to do it. And I'm going to create a new agent. So what do I mean by agent? Agent is nothing but the chatbot that you need to create. So let me name this agent trial, because I'm just giving a trial here. You can choose the default language, the default time zone, and if you already have a Google project, you can assign it to the Google project. If you don't, it's going to assign it for you. and you just click the create button. So while it is working through this, I'll just tell you a little bit about Dialogflow. So you can actually create your own chatbot here. You can specify the intent and you can specify the answers based on the kind of questions you can expect from the users. I'll just show that. So right now you are seeing two things on your screen. First, it's called for a default fallback intent, and second, default welcome intent. What is an intent in the first place? Intent is nothing but something you're anticipating the users to ask. Like for Alexa, how is the weather outside? Can you read my email? Hey, please schedule something for me. Remind me, set an alarm. All of those are intents that you can expect the user to ask you. So, that is an intent. So, by default, Dialogflow, as soon as you create an agent, has two intents defined for you. First is the default welcome intent. In this, you have a lot of welcome messages that is being stored for you. So, if anyone comes into your chatbot or the chatbot pops up, there's a default message that's been provided to you. Next, you have the default fallback intent. What is a fallback intent? Fallback intent is when something has been typed in the chatbot that is not recognizable. Like there's something maybe that is not being specified, or they're asking something completely weird or different. I didn't get that. Can you say it again? Sorry, can you say that again? All of these fallback intents are actually provided to you by this particular chatbot. So this agent already has pre-filled welcome and fallback intent, and you really don't need to do anything right at this moment. So I'll just give an example. So there's a try it now button here in which I can try anything. So I can just write, hi, hello, how can I help you? So this is the default welcome intent that was provided to you by the chatbot. So you didn't do anything, right? Did you see me write a single line of code or a sentence? No, this was already predefined for you. Now let me type something really, really weird. I'm just writing RV. What's the default response you see here? Sorry, can you say that again? This is the default fallback intent that's been provided to you. So right now you have a functional chatbot, but the only thing that have been fed in this particular chatbot are intents, fallback intent and welcome intent. So it will just say hello and bye-bye to you, that's all. But we need to actually specify it a little more, right? So let me create a particular intent. Let's say I want to create I want to create a chatbot for scheduling an appointment on my website. So like I'm giving a lot of talks and all, but I want to just automate this process. I don't want to keep responding to everyone, so I want a chatbot to do that for me. In this, we have different words here, and training phrases is extremely important. So what is a training phrase? Training phrase is something that you expect the user to say so the chatbot can respond in an appropriate manner. It doesn't really need to be to the point, like I can phrase it a little differently, but it needs to be a little similar. So you need to think about words that would make it all inclusive and not really, really specific. So let's say, schedule an appointment for a session or whatever. See, I'm not writing for a session and I'm not being too specific, but just schedule an appointment on Monday at 10 p.m. What happened here? So the minute I did that, it got fed into its brain, this particular training phrase, and the Dialogflow actually picked this entity up as date and time entity. So it could automatically read that. So it would know, okay, this is the date and time entity. Now, we have specified the training phrase. Now we have to specify a response to that particular training phrase. So we click on add a response. So what would the response be? Thank you. Your appointment is confirmed. You can either say that or just take it up a notch, put on a $sign, at date and time. Remember the particular parameter it read a while ago, at date and time. You can add this particular response and you can save it. What did I do? I just set one particular intent and response, so training phrase and response for the particular chatbot. Let me just try it out. Let me not even say Monday. Let me just say something different. At 1 p.m. So I just wrote schedule an appointment on Friday at 1 p.m. And what's the default response you saw? Thank you. Your appointment is confirmed on 2021, 1st of October at 1 p.m. It's as simple as that. Did I write a single line of code? I did not. And all of this is running on the cloud. That is, it's really easily customizable. You don't have to do anything to delete, or you don't have to do anything to maintain it. And it is as simple as just typing one sentence. You can do this really, it's really simple. You can have as many training phrases or anything you want in this to make sure that your particular chatbot is active and functional. I'll just show an example now. So what if you have this created for you, but you want to embed it on your website? I'm so sorry. Just remember to save this one. So I go into integrations. As you can see here, you can integrate this particular chatbot on various other applications and mediums. You can have a web demo. You can have it on Messenger on Facebook. Like if you have a Facebook business page, you can use this, or you have a web demo. So I'll just click on web demo here. I need to enable it. And this is the web link. So this is the web link that you can use on your website, or you can just embed it using this HTML code if you want. And here you see the chatbot has been opened for you. Let me do. Since I've just used one training phrase, I'm going to reuse that. Schedule an appointment on, let's see, Tuesday at 2 p.m. While it's working through for you. Thank you. Your appointment is confirmed on this date at 2 p.m. It's very simple. You can always try this out, and you can embed this particular little box on your website as and when you want. You can have it pop and open up by suggesting some of the events, or you can have it on various open sources, or you can use it on Telegram, like if you have a business page on Telegram, on Facebook. Anything else you want, you can use it there. So it has various different integrations, also with Google Assistant. So now this is one example of feeding in different entities, different conditions. But there can be endless conditions, right? So what if you already have a good FAQ page? Like let me say Google Cloud FAQ page. Let me just open that. If you already have a nice FAQ page and we want to use this FAQ page in Dialogflow, why to just type this all out again, right? So Google decides to, for example, have a little chatbot here, but they already have such an amazing FAQ page with so much of information. What if they want to reuse this information for the Dialogflow chatbot? There's a really nice way to do that as well. So if you can see on the left-hand side, there's something called as knowledge. So knowledge is a beta feature that I have to enable first. So I'm just going into this. I'm enabling beta features and API because it's actually a very new beta feature that's still in work, but it's provided to you for free. Like I'm not paying anything for this right now. I've saved this in. I've gone to knowledge beta, and I'm going to create my first knowledge base. Let me call it the FAQ. So I'm creating my knowledge base called FAQ, and I'm looking at creating a knowledge document. So what I'm doing is I'm just referring an FAQ document and using the information in there. So let me just call this FAQ Google. And what is the knowledge type here? It is an FAQ document. So I'm clicking on FAQ. What is the MIME type? It's an HTML file. So you can even have a CSV if you want. What is the source of your data? You can either choose a file from your cloud storage bucket on cloud. Remember cloud storage, Google Cloud. You can choose a URL. You can use it from your computer. But because I have a URL here, let me just copy this particular URL and let me just have it here. There you go. I've just created a new knowledge base. What does creating a knowledge base mean? So it means that the particular assistant is going to use this document to populate its own responses. So all the question, answer from the entire FAQ document. It can be a huge FAQ document as well. It can be a 20-page long FAQ document. It can be a 5 to 6 page long FAQ document. It's completely up to you. So all of that is being populated by the knowledge base. So as you can see here, it's taking a little bit of time, but it's created. Now, if you go on to view detail, you can see what is the question, where can I find billing information, answer, question, answer, question, answer. So everything is being saved in the question answer format, and you don't have to worry at all about typing all of this out. So what did I do? In just a click of button, because I had FAQ document, I created a chatbot. I'm going to enable this and I'm going to add a response. So let's say if someone asks a question, refer to the answer section and you can see this. There you go, it's done. Let me just try it. So you don't really need to type the exact question as well. You can also say something like pricing. See, as soon as I write pricing, the default response is read the pricing page for detailed information on pricing, including how cloud storage calculates bandwidth and storage usage. It is as simple as this. So what did I do? I just uploaded a document on Dialogflow. I just typed a document, the document name. I just created a response. So even in response, I just asked them to refer to the answer section of this particular document, and the chatbot automatically got created for you. This is a very good example of also software as a service, and at the same time, the capability of the cloud because of the amount of data they use and all the analytics capability. Like if you can see here, there are a lot of things that go into play. The machine is sanctioned for you, the infrastructure is provided to you, there's analytics that is running in the background, your data is getting stored, like this particular knowledge file got stored. So all of it has beautifully come together on the cloud for you to form a chatbot. So this is what cloud enables you to do. Now, let me just go on to the integrations again, and let me use the URL to show how this is working. So here, your trial chatbot is open. Let me just see if there's any other question I can ask. Product feedback. I want to ask about product feedback. I want to give feedback, so I'll just say feedback. What will happen now? From the Cloud Suite documentation, click send feedback at the top right. So the entire instruction is given to you. I didn't type this out. It just referred to the document I had downloaded in the knowledge base. It's as simple as this. So if you have a website and you want to create a chatbot, you know how simple it is to do that, right? Just because of your cloud capabilities, which otherwise can be extremely cumbersome because this requires a lot of code running in the background, lot of data analysis, lot of data needs to be stored, maintained. There's a lot of overhead going on. This is how Dialogflow works. And I will just move on to the presentation. So we're done with the fun demo, and I'll move on. Next. So since I've given you a good overview or a good introductory session of Google Cloud Platform, talked about security, talked about artificial intelligence, cloud services, I want to gain more skills. You decide you're really interested in cloud. What can I do? So if you want online courses and professional certificates, Coursera, a Cloud Guru, Udemy, edX, Accredited Learning have really good professional certificates and online courses that you can do at your own pace. You can sit at home and do that, and you don't really have to go anywhere physically, and all of that is done for. And you can just use the expert knowledge of different advisors. Coursera has really good professional certificates and specializations in Google Cloud taught by Google Cloud instructors or developer advocates. So these are people who are working in Google and they are running courses for you. So next we have gaining skills. So if you want to do an on-campus course, just give me a second, please. Yeah. So if you want to run an on-campus course, like you decide, okay, I'm very, very interested in cloud, I've explored all of it, I want to do a master's. So you can do masters in cloud computing, data science, you can do masters in cloud and network infrastructure. There's masters in computer science with different concentrations. You can choose cloud or cloud security. And then you have masters in information assurance if you're really into the field of security. So all of this master's degree would help you actually gain more skills and more hands-on on cloud. And you can actually use that to maybe gain a PhD after this if you wish, or you can just pursue your master's and get a really good job. Next, we have certifications. There's a lot of buzz around certifications these days, especially the people who are just uploading certifications on LinkedIn, and a lot of certifications are being advertised. What is a certification? So using certification, you can actually prove to your companies or other places that you're interviewing at that you have good knowledge of Google Cloud and you have been certified by Google Cloud for having that knowledge. Typically, Google Cloud certifications have a set of questions. There are multiple choice questions, and you need to choose the right choices. And there's a minimum passing percentage, and you can pass if you have all the questions, if you have reached the passing score. So they're multi-choice questions. For certifications, you have foundation, associate, and professional. For foundation, there's just one course at the moment. It is called the Google Digital Leader Cloud Certification. But for associate, you have the Associate Cloud Engineer certification. Similarly, for professional, you have network engineer, architect, DevOps, security, machine learning, developer, and it keeps growing. The list is ever exhausting. So, depending upon what your concentration is and depending upon what your interest is, you can always choose one of these certifications and you can give it. You need to have really good hands on, and there's something called Quick Labs. I don't know if you've heard of that or not, but QWIKLABS. So using Quick Labs, you can always gain good skills. And 30 Days of Cloud, just a shout out to that because that's coming on. So in that, you can actually gain really good skills and hands-on for cloud, and you can attempt one of the certifications. So once you get the certification, you get a good certificate that stamped by Google that actually certifies you as an expert or certifies you as a professional in a particular concentration on Google Cloud. So that would be a really good asset to show to your companies or any place you're interviewing. And it can actually increase your salary or give you a good salary just because you have been certified by Google. And most important, it helps you grow your skills. So when you're preparing for a certification, I'm actually certified as an architect and security. It's a professional certification. So I learned a lot because in order to answer the questions, even though they're multi-choice, you need to have a lot of hands-on cloud. So these are the certifications you can pursue depending upon your needs. So, and also I'll just give an example of how the certification page looks like. If you go onto Google Cloud certification, you'll be redirected to a certification page. In this, you can actually navigate all the cloud certifications that's right for you. So like I said, there's a foundational cloud digital leader in which no hands-on experience is required, but you need to understand the products and the services that's been provided by Google Cloud. There's an associate level, and there's so many professional level certifications. Looker. If you have experience in Looker, you can always have a Looker certification. You have good resources on the left-hand side as well if you want some training, if you need some help. And like I said, Coursera, Udemy, or a Cloud Guru have really good resources for certification. You can always enroll into that and you can give your certification. And the best part now is in this virtual world, you can give the certification sitting at home. You don't really need to go to a center. You can sit at home as long as you have a clean surrounding. They're going to ask you to move your laptop to make sure that there are no unauthorized articles, unauthorized items in the room, and you can give your certification. It is as simple as that. I give both my certifications sitting at home. Moving on. Yeah. So research opportunities. Let's say you want to go into research and PhD or something like that, any kind of research. So you can do research in big data, cloud security, artificial intelligence, machine learning, and deep learning, like I just mentioned. How do machines think? Let me do a little bit of research on that. Next, we have DevOps, cloud cryptography, cloud load balancing, Internet of Things, green cloud computing, and containerization. I'll just explain some of the terms here that I haven't explained before. What is Internet of Things? So as you see, many of you might be viewing this particular webinar on your laptop. Some of you might be using a phone. Some of you might be using a tablet. So you need to make sure that your application is optimized for all of these things. So that's why it's called Internet of Things. You need to make sure there's optimization in terms of viewing. You need to make sure there's optimization in terms of speed, scalability, in any device that you use. Sometimes even Apple Watch, if people have that. Next is green cloud computing. Green cloud computing is nothing but having an eco-friendly way to run your applications. Like you need to make sure that the carbon emission is less, and you need to be friendly to the environment as well, right? So that is a really good research field right now, green cloud computing. So if you're interested in research, you can explore any of this. You can do a master's, you can go ahead. So long term, but do keep this in mind when you're concentrating on cloud. So that's it. Thank you so much for listening to me so patiently. And you can go to my website, clouddemystified.com, if you want to see some webcomics that I have created on cloud fundamentals and best practices. You can connect with me on LinkedIn if you have any questions, or if you just want to connect for further basis. And Twitter. I'm not very active on Twitter, but LinkedIn would be a good place to get in touch with me. And I'll give you a moment to type this out, and I'll hand it over to you, Rutuja. Thank you so much.
It was an amazing session, Vijeta. That was so knowledgeable. Like for us who are like beginners in cloud, it was a very, very amazing session. Thank you so much to be taking this session. Neha, as a okay, all of you guys, all of the you can type all of your questions in the chat box. So Neha has a question: does Google Cloud provide an environment with both CPU and GPU to work with machine learning and deep
Yes, they
learning?
do. So there are different levels of customizations. Like I said, you can choose on. So if you think that you want to customize the CPU and this GPU based on your needs and requirements, you can do that as well. But if you don't, there you can there's a provision for that as well. I just showed you an example of Dialogflow a while ago. You didn't really have to customize anything. It was highly managed by Google Cloud. But if you want more level of customization, like if you realize that you are very good at coding, you want to do it on your own, you want to specify the CPU and the GPU usage because there are some particular specifications, you can do that as well. So depending upon your requirements, your needs, and your expertise, it's highly customizable. So yes.
AWS or Google Cloud, which one is better?
I'm a Google developer expert for a reason, so I don't think I'm in the position to answer that right now. But the thing about Google Cloud is it's actually a very niche skill in the market. So I can just talk about myself, why I got really attracted to Google Cloud. It's a niche skill in the market right now. So not a lot of people have certifications, but it's a growing cloud provider. AWS has actually established itself as an industry expert in cloud since many, many years, even before Google Cloud started. So because of that, there are a lot of people who are using it. But Google right now, Google Cloud is one of the fastest growing providers. Like it's growing at a rapid pace. And for artificial intelligence, it is one of the most sought after cloud providers right now. Just because you just saw Dialogflow a while ago, just because of the various options, yeah, that are
Right.
being provided to you. So because of that, and also security, and there are really infrastructure also. So you've been using Google Drive, Gmail. So it's the same infrastructure that is being used by Google Cloud. So you have experience and familiarity in that, and you know how reliable it is. So from a reliability speed perspective, like throughput, Google Cloud actually provides more throughput as compared to AWS. So that's the reason why I realized that, okay, let me just invest myself in Google Cloud because it's one of the fastest growing cloud providers. With
Right.
fastest growing, there are two parts to it. It's like it is not well established, so there can be certain nuances, nicks here and there that you might need to work on. It's like a brand new shirt that you buy from the market. You need to iron those creases, but at the same time, you know it is new, so it is actually growing at such a rapid pace that you can always look forward to more and more. So yes, personally Google Cloud, of course, and that's why I'm an expert in Google Cloud as well. But yes, these are some of the differences, and if you wish, you can just connect with me offline and I can just provide a very comprehensive summary of what the differences are between the two.
And do we need to set the region and zone in Google Cloud?
It depends upon the kind of service that you're using. So if you're using infrastructure as a service, like I just showed you compute engine in the beginning, so if you're creating a virtual machine or something, you need to specify the region and the zone. So if you have a lot of users in India, you can use the Mumbai or the Delhi region. But if a lot of users in the EMEA region, you can, by EMEA, I mean Europe, you can choose that region or a particular zone in that. But if it's a software as a service that you're using, like Google Drive, you never specify a region or a zone, right, for Google Drive folders or any kind of files that you create on that. So it depends upon the kind of application you're using, the kind of service you're using. Some that are highly customizable have you ask you to choose a region and the zone, but the ones that are highly managed by Google Cloud, they don't require you to do that. So that's the answer.
Great, great. Any other question, guys? You can type it in the chat box, and all of them will be answered. If not, then we can end the session. So, do you have any question?
And even if you cannot think of a question right now, something strikes you after this presentation, or maybe midnight you get something, a dream about a question, you can always reach out to me on LinkedIn.
Is there any free trial available and for practicing Google
Yes. So
Cloud?
when you are a new
Are there
user, yeah.
facilities?
So when you're a new user and you sign up for Google Cloud, they provide you some credits so to use it. That's a small number, but at the same time, it's good enough to use. And also, some of these things are actually free of cost if you just want to play around. And other than that, you have Quick Labs, QWIKLABS. So when you sign up, you get Quick Lab credit. You can always use that to play around. There are different quests that you can do, like create a virtual machine, create a Kubernetes instance. So you can do that and complete those quests for free. So you can do that.
Right, right. So we have 30 days of 30 days of cloud coming up. We have it from 27. So all of you who have registered, you will get access to Quick Lab. So make the most out of that platform. That is an amazing platform where you can get hands-on, access to a lot of things out there. So yes, yeah. So I think we are done with the questions. Finally, I really thank you, Vijeta ma'am, to help us with this, like help the students with this session, give us so much information about Google Cloud and a hands-on experience on Google Cloud platform. Uh, we are in collaboration with Shani, the Rajguru College of Applied Sciences for Women. So, all the students from that college, bang on. I hope you really, really understood the technologies. You were there throughout the session. And yeah, so we can end the session if anybody has no questions. Thank you, everybody, for joining. And I also would like to thank the audience. You were there, so thank you.
Thank you so much. And do tune into Rushab's session tomorrow. I mean, he's really an expert.
Yes.
He has his own company, Agrahyah, that's doing really well. So he's an expert in AI ML. So any questions you have on that front, he's doing really well. His company is earning really good awards right now, just putting it out there. So do tune into his session as well.
Yes.
Thank you
So
so
we
much.
have tomorrow. We have the continuation of this session tomorrow at 8 p.m. So join and tune into the same session. The link will be provided to you. And yes, so see you tomorrow again.
Bye.
Bye bye,
Thanks a
Vijeta.
lot, Rutuja. Thank you. Bye bye.
Thank you.